folks, welcome back to the last example coming out of this section. So we're going to write these radicals as exponentials, right? Or rational exponential expressions, and then use any properties we want with rational exponents. And we're going to leave our answers in exponential form only because that's how the problem, or those were the instructions we were given. We can assume every variable has a positive real, or every variable represents a positive real number, so we don't have to worry about domain issues. So I'm going to take a look at A. I've got a product here, but I can see this first term, right, second term, multiplying them, right? So it's a product. Now I have m cubed to the fifth, or I should say not m cubed to the fifth root of m cubed, excuse me. So that 5, that's my index. That's ultimately going to be a fraction, right, when I go to write it as a rational exponent. So I have m cubed raised to the 1/5 power, right? My index here is a 2 and my radicand is m, so here I just have m to the 1/2. All right, now when I have a power raised to a power, I can multiply the exponents. So this is going to be m to the 3/5, because 3 times 1/5 is 3/5, times m to the 1/2. When I have a power times a power, I add exponents, okay? Power to a power, multiply. Power times a power, add. All right, so I'm going to take a look at m to the 3/5 plus 1/2. Those fractions do not have common denominators, so I'm going to switch them into common denominators. Let me put some equal signs here. All right, my common denominator, my least common denominator would be 10. So if I want a 10 down here, I'm going to multiply this by 2/2. So this is going to be 6/10. All right, and if I want a 10 to come out of this 1/2, if I want to rewrite 1/2 as something over 10, I need to multiply numerator and denominator by 5/5. So this is going to be plus 5/10. Let me put a little separation here so I remember where A and B get separated. All right, I've got common denominators. So when I want to simplify this, I will keep the denominator of 10, and then 6 plus 5 is 11. And I've kept my answer in exponential form, so I'm good there. All right, so let's use the same idea with part B. So I've got, if I look, I've got a cube root, right? So I've got my radicand of p to the 5th raised to the 1/3. I've got a square root, but this time my radicand was p cubed. Oops, that doesn't really look like a 3. Let me fix that. And then I've got that to the 1/2. Okay, power to a power, I'm going to multiply exponents. Power to a power, multiply exponents. So when I do that, p to the 5th to the 1/3 would be p to the 5/3. And then I have p, 3 times 1/2 is going to be 3/2. All right, when you have a power over a power, you can subtract those exponents. So I've got 5/3 minus 3/2. Again, I don't have common denominators, but my LCD here is going to be 6. So let's rewrite this. If I wanted 5/3 as something over 6, I'm going to multiply top and bottom by 2/2. So this is going to leave me with 10/6. Minus, all right, if I want 3/2, if I want 2 to become a 6, I need to multiply by 3/3, so that's going to be 9/6, right? And 10/6 minus 9/6 is 1/6. And again, I've left my answer with a rational exponent, right? So that's good. All right, so let's try this one. So I'm going to start outermost. I've got a 4th root. So this is going to be my radicand, which is cube root of x raised to the 1/4, right? Now I want to rewrite this parentheses, this term in the parentheses with the rational exponent. My radicand is x, it's raised to the 1/3 because it's a cube root. And then that whole thing is raised to the 1/4, right? Because I had the cube root of a 4th root. All right, but again, power to a power, multiply the exponents. So x to the 1/3 times 1/4. I don't need common denominators here because again, multiplying fractions is much more straightforward than adding or subtracting. So here I multiply numerators. 1 times 1 is 1. 3 times 4 is 12. And there's my answer. And I'm going to leave that as x to the 1/12 rather than writing that as a radical, right? Just side note, I don't know why I had to get quiet there. This is the 12th root of x, right? But the instruction said leave it in exponential form. So I'm going to leave it there. All right. Thanks so much, everyone. Bye.